Good afternoon, students. Last day I have taught you up till the laboratory preparation of ammonia. Hope so you have understood and answered the questions. We'll discuss the questions after the school reopens. So today I am going to discuss about the Haber's process. What is Haber's process? Haber's process is the industrial preparation of ammonia. So, as you can see the reaction I have written in the PDF, that is nitrogen will combine with the hydrogen to give ammonia. And the reaction is exothermic. So, in the product side, I have written heat. Now, there are several conditions. This reaction will not occur as simple as I have written it. Some conditions have to be obtained. We have to give certain favorable conditions. After that only the reaction will proceed. So first of all, the temperature. The temperature is optimum temperature 450 to 500 degrees Celsius. Now, as the reaction is exothermic, so in front heat is evolved. So as much heat is given. After this, if I am increasing the temperature, according to Le-Chatelier's principle, if a reaction is exothermic, the reaction with the temperature increase, the reaction will favor the backward side. Once again, I am repeating the same statement. According to Le-Chatelier's principle, when a reaction is exothermic, in that condition, when I am increasing the temperature, the reaction will favor the backward side. Now, why and what is this Le-Chatelier's principle? So, this means why we can say, suppose you are sitting in a room and at the door I am putting a fire. What you people will do? Obviously, will not run towards the fire. You will move out of the fire. Similarly, when a reaction is exothermic, the heat is produced in the front side. So, when I am increasing the temperature, obviously the heat will be more. And who wants to go in the heat, towards the heat? So, the reaction will also go away from the heat, that is backward side. And Le-Chatelier's have given this principle, that so we have told that it is Le-Chatelier's principle. So, since the reaction is exothermic, we will decrease the temperature so that the reaction will go in the forward side. Now, if we are decreasing the temperature very much, what will happen? The reaction amount of the ammonia produced will be very less. For that reason, neither a more temperature nor a very less temperature we are taking. What we are taking? In between the two. That is the optimum temperature. And what is the value? That is 450 to 500 degrees Celsius. Now the pressure. Pressure, we can see the reaction, that is 1 mole of nitrogen reacts with 3 moles of hydrogen. That means if we add the reactants, how much we are getting? 3 plus 1, 4 moles of the reactant. So we can see 4 moles of the reactants are reacting to give how many moles of ammonia? 2 moles of ammonia. In this situation, when this is the condition, again according to Le-Chatelier's principle, that when the reaction is proceeding with the lower in the volume, what will happen? How much pressure we will increase, more the reaction will proceed towards the front side, towards the product side. Here also same, 4 volumes of the reactants we are taking and we are getting 2 volumes of ammonia. Therefore, the reaction is proceeding with the decrease in the volume. And if this is the condition, then according to Le-Chatelier's principle, how much pressure we will increase, more amount of ammonia we will get. But again the same thing happens, that here various amount of the machine, since it is the industrial preparation, so the things, the pipes and the compressor, all these things will not be able to hold that much of pressure. For that reason, a pressure little bit lower pressure is given. Again the word optimum is coming. We are giving 200 atm. Now the catalyst. So again the catalyst definition is not new to you people. That is, a catalyst is a substance which will increase the rate of the reaction. So here also we need the catalyst, and it should be finely divided iron. Next again the point comes, why the finely divided? Why finely divided? Because if we are dividing finely, surface area will increase, and since the catalyst is a surface phenomenon, so we can tell that the amount of the surface for reaction will increase. Therefore, we are telling that it should be finely divided iron. Next, the promoter. The promoter is aluminium oxide or the molybdenum, that it will increase the efficiency of the catalyst. So these are all the favorable conditions which is needed for the reaction to occur. So these are all we can from the Haber's process. This is the important part. Now again one thing, that is the catalyst some impurities are there. So before the catalyst is put in the catalytic chamber, we have to purify the impurities, or otherwise it will poison. So what are the impurities? For example, sulfur compounds, H2S. So this type of compounds, or carbon monoxide, carbon dioxide, this will poison the catalyst and is also called the catalytic poison. So these are all about the Haber's process. So now next we are discussing about chemical properties of the ammonia. Before that, first let us discuss about the physical properties. So physical properties, more or less you know that it is highly soluble in water, vapor density, it is lighter than air. Already we have studied in the laboratory preparation of ammonia. It is alkaline in nature. Okay, so the fountain experiment we are going to study in the in your physical properties. So the fountain experiment, just see the figure. The figure which I sent in the PDF, just see the figure. What is the arrangement? A round bottom flask is kept in the inverted condition, and it is dipped in the red litmus solution. And from the side a dropper is kept in which water is there. And in the round bottom flask, in the bulb part, what is there? Ammonia gas is there. Now what we will do, first thing, we will squeeze the dropper. As soon as we are squeezing the dropper, water is coming out from the dropper. And the water which is coming out, ammonia is highly soluble in water. Therefore, the water and the ammonia will react to give the ammonium hydroxide solution. Now, just think the volume of the gas. Earlier it was ammonia gas. Now it became ammonium hydroxide solution. So obviously the volume of the gas is much more as compared to the volume of the liquid. Now liquid is there. So the volume is less and the pressure outside is more. So what will happen? The red litmus solution through the delivery tube will rush through the delivery tube, and as soon as it is coming in contact with the ammonia being basic in nature, the red litmus solution will show the blue fountain. So this is your fountain experiment. And what is the aim of the fountain experiment? It is the aim, that is, ammonia is highly soluble in water. So children, this is just same as that of the fountain experiment in HCl chapter. That chapter we have already studied. So HCl chapter and ammonia, this two differences there. HCl, since it is acidic in nature, so the fountain you saw, it was the red fountain, and ammonia, since it is basic in nature, so you saw it is the blue fountain. So from here another thing is important, that it will prove that ammonia is basic in nature because it is the blue fountain. Okay, so this part you will study very nicely. And another thing, that is a bottle of the liquor ammonia should be kept very carefully, and while we are opening it, we should keep it inside the cold any of the tray or ice tray we will keep. Why? Because inside the ammonium hydroxide, a huge amount of the pressure is there. And as we are opening the ammonium hydroxide, if we are cooling it with a decrease in the temperature, the pressure will also decrease, and therefore the accident will not occur, or otherwise accident can happen. Okay, so all these are about the physical properties of the ammonia. Go through this part. Next day again I will send some questions. Please answer those questions. Thank you, students.